For question number 2a, we need to solve the inequality we have over here. And to do that, we need to multiply both sides with x plus 3 whole square. We cannot multiply it with x plus 3 alone because it might be a negative number which would flip the inequality sign. So to avoid that, we need to multiply both sides with x plus 3 whole square, which must be positive for all real values. So we multiply this with x plus 3 whole square on both sides. Then we remove this term to the left. We do not expand the brackets. We move this to the left and we take x plus 3 as common, or else we would have to solve a cubic function, which we cannot directly do in F2. So we take x plus 3 common from both sides and we get x minus 5 times x plus 3 minus 9. From that we get this quadratic equation, which we can solve directly. And from this we get the values. We can factorize this quadratic term over here in x minus 6 times x plus 4. So now we get the three critical values: x equals to minus 3, x equals to 6, and x equals to minus 4. Now we will test the regions that come. We will plug in a value where x is less than minus 4 and check if this is less than 0. And then we will do the same for a value in the range this, then a value in the range of this, and then a value which is greater than 6. So for x equals to minus 5, we get minus 22, which is a negative number, which is less than 0. So this is an acceptable region over here. This region over here, we will test it now. I'll check for minus 3.5, and it's positive 19 by 8, so we cannot take this. Now for the next region, I'll just check 0, which would be negative 72. So this is also within the range. And for greater than 6, I'll test 7, and this is plus 110. So this region is also not included in our inequality. So the regions we need are x less than minus 4 and x between minus 3 and 6. So that's the answer. We can write it x less than minus 4, and so this is the inequality we want for part A. This is the answer we needed. So for part B, we have the same inequality, but the difference here is that x plus 3 is in the modulus. So the best way to do this is think graphically. So we have the set of axes over here. Let's draw x minus 5 here. So we have the line x minus 5, and then let's draw 9 by x plus 3 without the modulus first, which would be this. This black one is 9 by x plus 3. So this point over here is the value 6. It's 6 over here. This value is minus 4, and this is the asymptote, which is at minus 3, x equals to minus 3. So let's see what happens if we take x plus 3 in a modulus, and this is the graph we get. This black part won't be here, and this is the graph of this. So we see that the cutting point at x minus 4 is no more, and we need x minus 5 to be less than this. So we need the blue graph to be under the black part, and we know this point is at x equals to 6. and we want the blue graph to be under the black graph. So it happens when x is less than minus 6. Everywhere else, the graph for 9 by modulus of x plus 3 is over the graph of x minus 5, except when it's greater than 6. So the answer we have is x less than 6.